will see how to detect a loop in a linked list. For that, I took two linked lists here. So here linked list 2 is a normal linked list, you can see here. So it just ends with a null, which means that there is no loop. But the first linked list is having a loop. For example, 1, 2, 3, 4. And the fourth, the next node is not null. If it is null, then it is the end of the linked list. But here, fourth, the next node is 2. Which means that if I print this linked list 1, then it will be keep on going. So it will just keep on going in a loop. Okay. So how to detect a loop in a linked list? For that, here we are going to use, as usual, 2 pointers. So here we are going to use a slow and fast pointer approach. So we know that slow pointer goes by 1 hop and then fast pointer goes by 2 hop. Normally, this process ends when the fast reaches null or fast not next reaches null. So I will write it here. So this loop ends, this process, this slow pointer and fast pointer approach ends when the fast pointer reaches null. We have to check both the conditions. So fast pointer reaches null and then fast pointer next reaches null. So normally this process ends when the fast pointer reaches null or fast pointer next reaches null. But here if you can see here we are having a loop. So you can see here we are having a loop, which means that it will keep on executing. This loop keeps on going. So we have to stop this condition. So for that we have to check a condition like, so here we have to check a condition like slow pointer equal to fast, then we have to break this loop, or otherwise if we are returning a boolean value, then we have to return 2. Here in this example we are going to return the node, so where we are having a loop. For example, if you take here, so the loop occurs at 2. So I have to return the node 2. So how to do that in code we will see next, but I will just repeat this explanation again. So what we are going to do, we are going to take 2 pointers, slow pointer and fast pointer. Slow pointer moves by 1 hop and then fast pointer moves by 2 hop. Normally this process ends when the fast pointer reaches null or otherwise fast pointer next is null. But here this process won't end because it is having a loop. It is not having any null or anything. So this process is keep on going. So we are using this condition. So we are going to check it will go in a loop till the slow is equal to fast. If both are equal, if slow and fast are equal at one point, it will be definitely equal at one point if it is having a loop. So if it is equal, then we are returning, yeah, it is having a loop. Or otherwise, in a normal node, fast or fast dot next reaches null. If fast or fast dot next pointer is null, then it means that it is not having a loop. I will tell it again. In a normal linked list, fast pointer reaches null or otherwise fast pointer next is null. In that condition, I can tell it reached the end and it doesn't have a loop. If the fast pointer is not null, or otherwise fast pointer next is not null, in that case I have to check whether the slow and fast pointer are equal. If it is equal, then I have to tell it is having a loop. So here in this example, I am not going to return a boolean value. Instead of that, I am going to return the node itself. So here if you see, we are having a loop at 2. So I am going to return the node loop 2. So how to implement this approach in code, we will see next. So now we will see how to detect a loop in a linked list in code. So for that, as usual, I took one main method. So in the main method, I created one list and here I called this method. I will show you which code I written here. And then I created one more method here. You can see that one. So which is an empty method. I just returned null. So here I am using optional because in one condition I have to return null. So to handle that condition, I'm using optional here. So from Java 8 we can use this feature in Java. And then so for the so first I have a method here which is list dot insertion. So I will just show it here what I did here. So I simply inserted nodes in this method. So you can see here, so first node is 1 and I created a common node. So we are going to check whether the linked list is having a loop or not. For that purpose, so this node 2 has to have the same address. That's why I created here one node 2 and then I used this 2 in 2 times, which means that we are having a node like this here. Means that we are having it here like 1, 2, 3, 4 and then again 2, which means that this linked list is having a loop. So I just inserted nodes like 1, 2, 3, 4 and then 2. So you can see here I printed this list before adding the loop. Why? Because if I add this line here, then this loop will keep on going. So we can't stop this one. So that's why I added print here before this one, before we are having the loop. So which means that we can only see 1, 2, 3 and then 4. So now we will see how to implement this code. So we already took a linked list which is having a loop. So if you are having any doubt or something, then you can see my GitHub account. I just uploaded all these codes in my GitHub account. And I just mentioned my GitHub account in description box. Okay. So now we can start. So what is the first thing we have to do? So I have to create the slow pointer and fast pointer. I'm just creating a slow pointer and then fast pointer. So both are at the head for the first time. I think we need to import this node. So this is the node which this is the linked list which I created. So I'm going to implement the node from the linked list which I created. So if you want to know the code of linked list, you can see my previous videos, or otherwise you can see my GitHub account. Okay. So I created a slow and fast pointer. So what we need to check usually, so I'm going to loop it, and normally the linked list ends when the fast reaches null. So I'm going to give the opposite condition so that the loop ends if fast not equal to null, and then fast dot next not equal to null. So this loop has to execute till fast not equal to null, and then fast dot next not equal to null. And then so we know that slow pointer goes by one hop, which means that it goes by one step, and then fast pointer goes by 2 hop. Fast pointer goes by 2 hop. And then the main condition is if the linked list having loop, then this loop will keep on executing. That's why we are checking like slow equal to fast. So remember one thing here, we have to check slow equal to fast. We should not check like slow dot data equal to fast dot data, because this slow means it has having both the address and then data. So we have to check both the data and the address. So we already saw. So here we are using only one minute. So here in this linked list.java, so we are using the same node twice. Which means that both are having the same address. So this loop and then this loop is having the same address. So we have to check it here like slow equal to fast. If slow equal to fast, then we are going to return break. If you are returning a boolean value, then you can return true here. Okay. This is the normal condition. So which means that linked list is having a loop. Then we are checking this condition. If it is not having a loop, which means that if fast equal to null, or otherwise fast dot next not equal to, okay, fast dot next equal to null, which means that it is a normal linked list, then what we have to do? We have to return null. In this case, I am having an optional value, so optional dot empty. I'm just returning optional dot empty. So if it is a normal linked list, then it means that it doesn't have a loop. So I'm returning a normal one. Or otherwise, so I will just write it here. In case of normal linked list, in case of normal linked list, I'm just returning the null value. If it is not a normal linked list, okay, if linked list has loop, then what I'm going to do is I'm making the slow. So here slow pointer will be at the middle or at the end of the linked list. We don't know where it is exactly. So I'm making the slow pointer to the head again. And then I'm checking condition like slow not equal to fast. So this loop has to execute till the slow equal to fast. Okay, that is the meaning of this one. So if while slow not equal to fast, then I'm moving slow and fast pointer by one hop. Moving slow and fast pointer by one hop. Here the import, usually we slow pointer goes by one hop and then fast pointer goes by two hop, but here we need to find the node which is the node which is looping. So that's for that purpose I'm moving both the nodes by one hop, and then I'm returning fast dot data. Here I'm using optional dot nullable of fast dot data. So here I'm going to print this one, loop here I'm going to print this loop node. So we inserted elements like 1, 2, 3, 4 and then 2. So it is having a loop at 2. So here I have to get 2 as answer. We'll just execute and check it again. Yeah. So if you see here, we are having the loop at 2. And we printed till 4 because we already saw, I already said that if I print it again, then it will keep on going. So here we get the loop like 1, 2, 3, 4, 2, again 2, 3, 4, 2, then it will keep on going. So that's why I didn't print the last element. We can't able to print the last element. So now what I'm going to do is I'm going to insert a normal linked list and I'm going to check whether it is working or not. So here instead of loop, so I used the second node itself 2 times, right? So here I am going to insert the node 5. Here I am going to insert the node. It means that it is a normal linked list. We are having 1, 2, 3, 4, 5. In this case, I have to get null as an answer. So we'll check I am getting null or not. So I'm getting optional dot empty, just null. So here I returned optional dot empty. That's why I'm getting empty value. So I will explain the logic once again. So I already showed you. So I just inserted nodes here. So which is insertion at tail, and then if it is a loop, I have to insert the same node twice. So here is the logic. So I took 2 pointers as usual, slow and then fast pointer, and then I'm just looping it. If looping it till fast reaches null or fast not next reaches null. So we know that slow pointer goes by 1 hop and then fast pointer goes by 2 hop. So here when the linked list is having a loop, then this loop will keep on executing. It won't even reach as null because fast pointer won't reach as null. It will keep on executing. That's why what I'm doing is here I'm checking a condition like if slow equal to fast, then I'm just breaking this loop. Okay, so again I'm checking once again if the fast reaches null or otherwise fast dot next reaches null, which means that it is not having a loop. So in case of normal linked list or otherwise, if it is not having loop, then it reaches, then I'm returning a empty value, or otherwise I need to return the node. For that purpose I'm making slow pointer again to the head, but the fast pointer still be at the position. We are not sure whether it is at the middle point or at the end of the point. So I'm going to loop it again till slow and fast were equal. So I'm moving both the pointers by one hop, and then I'm going to execute this loop till slow and fast pointer is equal. If it is having a loop, then I'm going to execute this loop till slow and fast pointer are equal, and then I'm going to return the fast dot date. So this is how we detect a loop in a linked list. So it is this question is asked in a few interviews also. So if you want this code, then you can get this code from my GitHub account. I just provided my GitHub account in the description box. Then thank you und haben Sie einen schönen Tag.